Hi there, this is Professor Smith, and I wanted to walk you through some TVM or time value of money applications using your calculator, either TI 83 or 84 or Casio. When we go into the TVM solver on the Texas Instruments, you press the Apps button and then enter 2 times to get into the TVM solver. On the Casio, you press the menu button and you want to select option C, so you can use the large round circle to arrow over and down until you get there and hit execute, or you could just press the LN button that has a red C above it. Then you need to select F2 for compound interest. First value that we fill in here is N, which is the total number of payments. And we find this by taking the number of payments per year times the time in years. And whatever this number of payments per year is also goes down into the PY in your calculator. So say I have monthly payments for 5 years, I could put 12 times 5 in for N. And when I press the enter or execute key, it will return the value of 60. Next is the I%. This is the interest percentage. You do not have to convert this to a decimal equivalent. You should use the annual percentage rate. Next is your PV, which stands for present value or principal. This is a one-time only value, for example, an investment or deposit. Uh, The problem might say today if it wants you to think of present value or think of currently at the moment. The next is PMT, which stands for payment. This is a regularly occurring payment or periodic payment as opposed to the present value or principal, which is a one-time only thing. Next, we have FV for future value, and that would be used if we were looking, say, for the value of an investment or loan after some period of time. And finally, PY and CY I typically group together because they always need to be the same. And we talked about PY already being one of the factors in calculating your total number of payments, N at the top, and it is also equal to CY, and these are equal to the number of payments and compoundments per year, typically 12 for monthly, but it could vary. So the first example I have here says to find the future value of $1,000 invested for 10 years at 8% interest with 4 different levels of compoundment: annual, semi-annual, quarterly, and daily. So I have provided you with each of the frequencies of compoundment and the numbers plugged into the future value of compound interest formula. However, I want to teach you how to do this on the TVM server. So when we're finding the future value of $1,000 for 10 years at 8% interest, our N is annual compoundments 1 times 10. And when we type that into our calculators, it will return 10. Our I% is 8, and our PV is our $1,000 investment. There is no payment. We don't know the future value, and the PY/CY should both be 1 for annual compoundments. Now, if you have a Texas Instruments calculator and you wanted to solve for the future value, you would put your cursor right here, press the green alpha button, and the enter key. If you have a Casio, you would type in each of these values and then press F5 to solve for the future value. And we saw that answer just a minute ago. It should be $2,158.92. You can watch me work out this process for the next several examples. And so as I move down the line, you can see that the only thing that's changing in these problems is N and the PY/CY, because compoundments are changing. So for quarterly, we have 4 times 10 years at the same 8% with the same $1,000 investment. Dono payment, dono future value, and the PY and CY are for quarterly. Finally, daily, they're typically going to have you use 360 days per year, which is the banker's rule, allows the banks to make more money off of you. And so I'm showing you each of the values that will need to be entered in your TVM solver to find the appropriate future value of this investment. Moving along, I have a future value of continuous compound interest, which is given by a formula which I like to refer to as PERT. That is PE to the RT power. So if you're still in your TVM solver, you're going to have to press on the TI second and quit, which is the button right next to it, or on the Casio menu and the number 1. I would encourage you to first locate your E button before proceeding with any formulas involving compound interest. And it's usually accessed by pressing a colored button before the LN key. So on the TI, I press my second, which is almost the total top left. And then the LN button is 2 above the on key on the left-hand side. On my calculator, that opens up a parentheses for me. If yours does not, you will need to insert an open parentheses, which can be found above the 8. On the Casio calculator, to access the E button, you have to press the yellow shift button before the LN key, and that gives you an E to the exponent power, and you will have to open a parentheses because we will be multiplying within the exponent. So now that you found your E button, I'm going to briefly talk about example 2, which says to find the future value of $890 invested at 21.3% for 3 years, 240 days, compounded continuously. And I have shown you that here we're going to use a 365-day year, no banker's rule with continuous compound interest. And so 3 years and 240 days gives you a fraction of 1,335 divided by 365. Leave it like that. If you want to reduce it, you can, but it's unnecessary. What I'm trying to say is do not use the decimal equivalent because it's not the equivalent. There's more digits trailing after that 7 that you cannot see. And to get the best answer, just use the fractional representation of the time. So I have the total number of days divided by the number of days in a year, representing my fraction, so to speak, of a year. It's an improper fraction representing more than a year. And plugging 890 in for P in the formula, multiplying that by E, which I don't need the multiplication sign unless it makes me feel better. And when I raise it to the exponent power, make sure you put in open parentheses in that exponent, but it's not going to let me, of course. We'll be multiplying 0.213, which is the decimal equivalent of the given percentage, by the time in years. And so the calculator should give an output something like this. And rounding to the nearest cent and using appropriate units, we have a future value of $1,939.68 because that 6 right there tells us to increase that 7 by 1. Inflation is an application of continuous compound interest. So if we had a salary today of $55,000 per year, in 20 years with a constant rate of 6% inflation, we would take our principal of 55,000 and multiply that by E. So second or shift ln, raise it to the exponent power of open parentheses 0.06 times 20, and the Casio definitely wants us to close our parentheses. I'm not sure if the TI requires it, but when I do that, let me see if I can put it in here, I get $182,606.43. would be my salary of $55,000 today, projected in 20 years with 6% inflation, and inflation is considered to be compounded continuously. Here's another example I have. Say you want to take a trip to some tropical place. Oh, doesn't that sound nice right now in 5 years? And you decide that you will need $5,000. So you're going to need that $5,000 in the future. So the 5,000 goes in as the future value. To have that much money set aside, how much should you deposit now? That's a one-time only deposit, so that means we're going to be solving for payment. I don't know that right now, but I need to hold the spot. To deposit now into a bank account paying 6% compounded quarterly. Okay, well, quarterly is 4 times a year times 6 years is 24 total compoundments at an interest rate of 6%. And I don't know the present value. That's actually what I'm looking for. And the PYCY are quarterly compoundments. I might have accidentally said we were solving for the payment at first, but this is not a recurring payment. It's a one-time only deposit of right now. So when I type these values into my TVM solver, I need to make sure that I am on the end setting when I solve these. So I've got everything in there and I want to solve for present value. So on the TI, I put my cursor next to PV, I press the green alpha button and then the enter key. On the Casio, I believe F3 solves for present value. And I am getting here $3,497.72 when rounded appropriately to the nearest cent. I think I might have time for one more example in this video. Feel free to pause or fast forward or slow it down as much as you need. And don't forget to like and subscribe. So next we have the ordinary annuity formula, which, as you've noticed, I haven't been teaching you really how to use the formulas because I think the TVM solver is so much better and easier to use if you understand each of the variables. So, example 5, how much do you save in 5 years if you deposit $60 at the end of each month into an account paying 12% compounded monthly? So they're looking for the value of the annuity at the end of the 5-year time period. It's just trying to get all of these in view at once. Okay. Sorry. So in my TVM solver, you'll note I already filled out N is 5 times 12 or 60. I percent is 12%. Don't confuse that for the monthly compoundments. Maybe I should put 12 times 5 here instead. Not that it matters, but the present value is unknown. The regularly occurring payment is $60. Future value is what we're solving for, and the PY and CY are both 12 for monthly. So if I have a TI, I'm going to put my cursor next to the FV to solve this. If I have a Casio, I'm going to press F5 to solve once I have all of these values typed in. So solving for FV gives me $4,900.18. Oh, it doesn't want it there.